There are moments in Earth's history when the planet does not merely change, it turns a page so completely that everything before becomes almost unrecognizable. Travel back more than 2.5 billion years. The world before us feels unfamiliar, even alien. The sky above is dim and hazy, colored by gases that no longer dominate our atmosphere. The oceans below are dark, heavy with dissolved metals. Life exists, but only just. It is simple, microbial, and fragile, clinging to environments that would appear lifeless to us today. And then, almost imperceptibly at first, the air itself begins to transform. An invisible revolution is underway. This is the story of the Great Oxygenation Event, the moment Earth learned to breathe. We arrive on an ancient shoreline around 2.7 billion years ago. There is no wind moving through leaves because there are no plants. No animals stir. The land is silent, barren, rust-colored stone stretching toward a hazy horizon. The surface bears the scars of volcanism and erosion, shaped by forces far older than biology. The atmosphere is thick with methane and carbon dioxide. Oxygen is nearly absent and highly dangerous to most life that exists at this time. Without an ozone layer, ultraviolet radiation from the sun reaches the surface unhindered. The sun itself appears dimmer through the haze, its light scattered by unfamiliar skies. In the shallow seas, microbial mats cling to rocks and sediments. These communities are dominated by cyanobacteria, organisms that have been quietly releasing oxygen as a byproduct of photosynthesis for millions of years. But the planet has been absorbing it all. The oceans act as a vast chemical sponge. Dissolved iron reacts with oxygen, forming rust that sinks to the sea floor. Layer upon layer of iron-rich sediment accumulates, locking oxygen away from the air. For a very long time, the atmosphere remains unchanged. The sky does not yet reflect the revolution happening below the waves. Time accelerates. Millions of years slip past like waves eroding stone. Cyanobacteria continue to spread across shallow seas, harvesting sunlight day after day. Oxygen production continues relentlessly. Eventually, the oceans reach their saturation point. There is nowhere left for the oxygen to hide. And for the first time in Earth's history, free oxygen escapes into the atmosphere. At first, the change is subtle. Oxygen concentrations remain low, barely detectable. But the process is unstoppable. Methane, once abundant, begins to break apart in the presence of oxygen. The planet's greenhouse weakens. The sky starts to clear. Sunlight grows sharper, harsher, more direct. For anaerobic life, this new gas is poison. Oxygen attacks cellular machinery, disrupting metabolic pathways refined over billions of years in its absence. Entire microbial ecosystems collapse. Extinction spreads silently, globally, without fire or impact. This is not just an environmental shift. It is Earth's first mass extinction, driven not by geology, but by life itself. Between roughly 2.45 and 2.3 billion years ago, the consequences ripple outward. As methane disappears from the atmosphere, global temperatures drop. Ice advances from the poles. Glaciers expand. Earth may enter periods of near global glaciation, possibly freezing from equator to pole. Snowball Earth may be born here, not from the failure of life, but from too much of its success. Yet, even amid the cold and collapse, new opportunities emerge. Oxygen enables powerful chemistry. It allows organisms to extract far more energy from organic molecules than was ever possible before. This energy surplus changes the rules of survival. Some organisms adapt. They learn not just to tolerate oxygen, but to use it. Respiration appears. Cells capable of aerobic metabolism gain an enormous advantage. They can grow larger, maintain more complex internal structures, and respond more flexibly to their environment. The future begins to diverge sharply from the past. As oxygen continues to accumulate, something extraordinary happens high above the planet. In the upper atmosphere, oxygen molecules interact with ultraviolet light and reorganize into ozone. A thin, fragile layer forms encircling the Earth. For the first time, the planet gains a protective shield against lethal solar radiation. The sun, once a threat to life at the surface, becomes a sustainable ally. Shallow waters grow safer, new environments open. Life gains room to experiment with size, complexity, and cooperation. The planet is no longer merely habitable, it is becoming hospitable. By the time oxygen levels stabilize, Earth is irrevocably changed. Rocks record the shift in their chemistry. Ancient sediments preserve evidence of oxidized minerals. The atmosphere has been permanently altered. The Great Oxygenation Event was not a single moment, but a long, uneven transformation, a biological rebellion against the old world. Those that survived inherited a planet with greater risks and greater rewards. Oxygen brought energy and opportunity, but also danger and instability. Evolution accelerated, branching into paths that were once impossible. Take a breath. That simple act connects you directly to this ancient catastrophe. The oxygen in your lungs once froze the planet. It once wiped out entire biospheres. And yet, without it, complex life, thinking life, reflective life would never exist. We are the descendants of survivors who learned to live in a changed world, of organisms that adapted when the sky itself turned against them. The Great Oxygenation Event reminds us that progress in the universe is rarely gentle. It is forged through imbalance, crisis, and transformation. And somewhere on distant worlds, beneath alien skies, perhaps another atmosphere is changing, quietly, gradually, preparing conditions for beings who will one day look back and realize that the air they breathed was once the end of the world.